Okay. Can you hear me okay? Hello, and thank you for being here. I'm Fabrizio Codella, and this is not working, I think. I can skip with this. Okay. I'm Fabrizio Codella from Chemours Company, and today I would like to talk with you about the low GWP refrigerants, especially for the heat pumps, and focusing on the opportunities to increase the adoption of these products in the European building renovation. This is a study we did in Chemours with our colleagues Hans Cooper-Ditter and Summerson. We all know that climate change is one of the biggest threats in today's world. And the refrigeration industry has a long history in supporting global policies to avoid global problems. So we had in 1987 the Montreal Protocol. The problem back at the day was the ozone depletion. It was discovered that old refrigerants was ozone depleting molecules. And so the industry found a new solution to avoid this problem, and new molecules like HFC came into the market. After that, and after the Kyoto Protocol, the biggest threat became climate change. And so the industry designed molecules that are now with low greenhouse gas emissions impact. These new molecules are the HFO. Nowadays, we are facing multiple problems. So, especially in Europe, we know that the reduction of the energy consumption is key, and to abandon the fossil fuel is also very important to have safe energy and safe and reliable sources of energy. In 2018, with the EU Green Deal, all the European countries pledged to reduce their impact on the environment and reduce their energy consumption. There are many ways and policies that have been implemented. One of these is renovation wave, which is aimed to reduce the impact of the building sector. Consider that now 40% of the final energy consumption is coming from the building sector. After the Ukrainian conflict, the REPowerEU entered into force in Europe and is based on the same concept. So to reduce the energy consumption, to diversify the energy sources, and accelerate the electrification of heating into buildings. The best machine we have to go into this direction is the heat pumps. Heat pumps is perfect for this purpose because it's high energy efficiency, so it can reduce the energy demand. Doing so, it's also reducing the CO2 emission coming from burning fossil fuels. And is also electricity driven. That means we can increase the renewable into the mix of our energy production. And also we can have heat pumps in cities without burning fossil fuels in the cities. This is also a good thing. Another thing to mention is that heat pumps is great to waste recovery. So when we have industrial plants or data centers or also retail supermarkets with waste heat at low temperature level, heat pumps are great to increase this temperature level and to be able to use this heat for other purposes. One other thing that is important to keep in mind is that if we move from gas boilers to heat pumps, we can heat with the same input energy 4 houses instead of 1 with the same energy. So consider the reduction. So, as we said, after the Montreal Protocol and after the Kyoto Protocol, the Kigali Amendment was implemented to tackle also the GWP of the molecules and not only the ODP. So GWP is the global warming potential. Many countries across the world ratified the Kigali Amendment. Here in Europe, we have the F-gas regulation that is in force from 2015, but also other countries are following, like the AIM Act in the US. This regulation the target of this regulation is to reduce the production and import of high global potential refrigerants into the market. Historically, heat pumps used 14A mainly in previous years, which has a GWP of 2088. And so it's important to lower this GWP. The first molecule that was adopted to reduce the impact of heat pumps and chiller was R32. You can see it as a GWP of 675. But there are also new molecules and new blends that can be used to replace 14A. One of these is 454B that we name Option XL41. And the other one is 454C, which is XL20. And you can see the reduction is significant, so we can have less than 500 GWP for XL41 and less than 150 for XL20. 150 is important because it's becoming a sort of a benchmark in many applications for the new limits. The 454B is really similar to 14A in terms of thermodynamics properties, so it's a perfect fit for equipment that was designed with 14A. While 545C needs a dedicated design because it's less, it has less capacity, so it's more efficient but less energy intensive. Our study focused on energy efficiency, energy consumption, costs, and emission for this kind of equipment, so for heat pumps. And as for the rating condition, we considered both new buildings and renovation buildings. So for new buildings, and the difference between these buildings is that for new buildings, we have new heating systems. So most of them are with underfloor heating that is using water at relatively low temperature, so 35 degrees. While in renovation buildings, sometimes it's useful to be able to keep the old heating system and use it with the heat pump. So it's necessary to have water at higher temperature. The minimum one to make the radiators work is 55 degrees. So we did a comparison between these refrigerants, considering all these parameters. What we did is a theoretical comparison. We developed a mathematical model of an air-to-water heat pump. It is a 10 kilowatt heat pumps made for residential heating. We developed it with RefProp 10 properties. We defined the temperature level, as I mentioned just earlier. And also, we define the climatic condition because we want to look at the performance during the whole year. In this case, you can see the temperature profile of Berlin. So we have the hourly temperature of occurrence. And you see the most of the hours in Berlin are around 10-15 degrees. So for the energy efficiency, we based our calculation with the Eco Design Directive. So we define the partial load based on the outlet temperature, ambient temperature. With that, we calculated the COP at any given rating point, so any given temperature. And with that, we have calculated the seasonal energy efficiency, so the SCOP. This is giving the overall performance during a year. As for the emission, we focused both on direct and indirect emission. This is an important topic because sometimes we confuse between the global warming potential and the total impact of an equipment. An equipment has inside the refrigerant, and based on the leakage rate, so you can see in the direct emission, the leakage rate, and the GWP, you can estimate the direct emission. But most important, when we go down with the GWP, the most important part is the indirect emission. These are coming from the energy production and the energy that is used in the equipment. So the less energy is used by the equipment, the less CO2 will be produced in the power plant to produce this energy. So to calculate this, we considered the energy yearly consumption and multiply it by the carbon factor of the country. So in this case, we have 300 grams per CO2, 300 grams CO2 per kilowatt hour in Germany. It depends on the country. It can be higher. I think Germany is a little bit lower, the average of European countries. As for the cost, we just focus on the energy costs. So again, the annual energy consumption is multiplied by the electricity price. In this case, it was considered constant, and I took the value from the second half of 2001. We all know that the prices are increasing, so all the consideration we made are reinforced by the fact that now the energy cost is rising, and it's more important to the end user that the selection goes into the direction of the most efficient system. So, going straight to the results, I show them all, and then I talk. So, for the SCOP, we see an improvement for, this is for the new buildings, so low water outlet. We see an increase for every new refrigerant that is possible to use instead of 14A, especially for XL20. I mentioned that the system needs to be a little bit bigger, but the energy efficiency is higher. This is reflecting also in the energy consumption. So the 14A is higher than R32 and 454B and 454C. Energy cost is reduced. And now if we focus on the emissions, you can see that the impact of the direct emission is really low compared to the indirect emissions. Going from 14A to XL20, we can reduce the direct emission of 93%. For the renovating buildings, so with water temperature of outlet 55 degrees, we notice that R32 is less efficient. That's because the temperature lift from to reach these 55 degrees is not in favor of R32 because it has high discharge temperature out of the compressor, while XL41 and XL20 are much better. This is reflecting into the energy consumption, the energy cost, and also in the total emission. So I go straight forward to the conclusion. We did this comparison of alternative refrigerants of 14A, focusing on residential heat pump application. We use the climatic condition of a typical German heating season. This can be extended for other countries in Europe easily. We consider two water temperature level for recent buildings and for renovation buildings. The results show that HFO 454B and 454C are high in energy efficiency, low in electrical energy consumption, and in annual cost. They reduce the direct energy emission of 93% and also the indirect energy emissions of 15%. Key message to take away with you is that the electrification of heating in Europe can benefit of these low and very low GWP HFO refrigerants to replace 14A. I thank you, and if there are any questions, I will be happy to answer. Those are all A2L. So yes, thank you for the question. All these alternatives to 14A are mildly flammable. So the flammability profile is higher than A1, but much less than A3. So you probably have seen many manufacturers proposing R290, so propane. The main distinction between R290 and these HFO products is the flammability. So especially for renovating buildings, it's important to avoid the introduction of new risks. This is because of to cope with the new risks, you can have higher costs, but also some end user are not able to use A3 refrigerants. So this is why we are finding refrigerants that are high in energy efficiency and that have a safety profile that is as much as possible similar to 14A. Okay, I get only one word, but I think I got the question. So the PFAS topic. Yes, we know that there are some questions about this atmospheric potential problem. There are other persons in my company that are evaluating and that are making studies on and if this can be a new threat, let's say, to the environment. So we take this with responsibility. But the evidence for now is, I would say, not strong enough to jeopardize the possibility to use these and to increase the adoption of heat pumps. Because what I personally believe, and I'm not speaking about my from my company, is that if we can reduce the energy consumption as much as possible and reduce CO2 emission, for our time is the best thing to do. And I hope I answered your question. Thank you. Okay, if there are no more, I thank you, and I will be here for any other question. Thank you.